future schedule. So today, May 18th, we have 3-hour lecture. And next week, we do not have any lecture because we move to May 29th, Monday, at ID 511-1, this room, and start at PM 6:30. We have lecture. And June 2nd, the week after next week, we also have lecture. So we have 6 hours lecture in the future. Then in June 8th, we will have final exam. So the final exam will be open book in classroom. So start from AM 9:10. And June 5th, we will have final exam review. So we will review our final exam. So the topic of the final exam will include AC to AC converter, which include cycle converter and matrix converter, and also DC to DC converter. So do you have any question about the future plan? Okay.
My question is about the writing of exam, how many hours?
I think final exam should be the same. So I think from 9:10 to 10:30, so 8 minutes, okay, and 18 minutes.
The June 2 and the June 8 is Thursday, not Friday.
Oh,
Friday.
this is not June
June
1st.
Yeah, June
Okay.
1st.
So this is wrong, should be June 1st. Okay, sorry. So this
Thursday and Friday.
This is June 1st, and the plus 7 should be 8, and 15 should be correct. Pardon me?
Today should be Thursday, right? Not Friday.
I check again.
Uh,
So I check again. Yeah. This is Thursday, sorry. Thursday. This is Monday. This should be Thursday. And Thursday. And Thursday. So any question should be correct.
Yeah.
So you can have a photo, and we will follow this schedule in the future. So I think we can finish the DC-DC converter, including soft switching, okay, in the future. So we watched 2 videos. It discuss about isolation converter, which means we put transformer between input and output. And also we discuss Choke converter, right, in the video. So it is quite clear, analyze every waveform. So to make it is easier to finish before assignment 2. So now I want to ask you some questions. If you have a cell phone, then you need a charger. So your boss asks you to design a charger. You say, okay, we have input voltage. It is 110 volt, 60 hertz. So what can I do? I design a transformer to convert 110 volt into 6 volt AC voltage. But the frequency is also 60 hertz because it is traditional transformer. Then what can I do? I design rectifier. So I put here, and I put here, I design rectifier. Then after that, I design filter. And I put my cell phone here. So this is low. So what is the voltage of cell phone? Maybe I need near 7 volt to charge the cell phone. So I can design 6 volt here. And then I can obtain 7 volt DC here. And you finish the design. And your boss say, there is something wrong. What is the first part? First part is your AC voltage is like this. But if you this circuit, then your current is like this. So what happened to your current? It is non-sinusoidal, right? And it is discontinuous. So what can you do? This is one question. The second question is, your transformer is like this. So you have primary side, you have secondary side. But your transformer in your PC board, this is your transformer. So it occupies 60% of your space. And you have huge capacitor here. So the other circuit is here. So your size is very huge. So every day, what should I bring? I bring a charger like this and a cell phone. So do you like to buy this? No. So your boss asks you, how can you solve this problem? So anybody has any idea? When I was young, I always use this charger because it is cheap. And I think it is good. This is my radio. So I buy a big charger. But at that moment, only this kind of charger, right? But the performance is not good. So what is power electronics? It should be small. It should be light. It should be thin. But your charger is too large, too heavy, too thick. So it's not good. So how can you solve this problem? So do you have any idea? This is a practical issue. When you work, your boss asks you to design a charger, and you think this is a good idea, but finally your charger is too huge. So what can you do? Anybody has any idea? How can you improve it? First, you have to put PFC. So I need a PFC here. So I need PFC. So if you need PFC, you need more space and more cost. So this is one issue. And how about the transformer? Transformer is too huge because if you go to the shop to buy a transformer to convert 110 to 6 volts, it is like this big. So how can you solve this problem? Anybody has any idea? Okay, please.
We can reduce transformer by converter.
Transformer by converter. But the problem is you need 6 volt here. And the problem is if you use a converter. What is converter? If you use a buck converter, so the buck converter could be like this. like this. Okay? So what is your input? Your input is 110 volt, right? And after you do rectify, so you use rectify. Then this is 150 volt, right? 150 volt. What do you need? 6 volt. So you design this circuit. It is okay. But one day, your switch fail. It become short circuit. Then what happened? This is 150 volt come here. Then the diode never turn on. So this is 150 volt. Go to your cell phone. Then what is the next step? Your cell phone burn out. Do you like this? So you can design this circuit, but it is dangerous. Why? Because the input is 110. The output is 6 volt. But you do not isolate input and output. Right? So 110 go direct into your converter. Do you like this? So what can you do? Anybody has any idea? So this is the problem of non-isolation. If your switch is always okay, then no problem. You can control duty. So you can control duty to control. This is 150 volt, but the duty cycle is 0.03. So the average is 5 volt. No problem. But one day, your diode fail or your switch fail, then 150 just go to low. Your cell phone is very expensive. Your charger is very cheap. Do you want to buy a cheap charger to burn out your expensive cell phone? It is too dangerous, right? So nobody will do this. So then what will you do? So this is a very common issue. So your boss say the customer don't like this because it is too dangerous. And if our product burn out one cell phone, then tomorrow's newspaper will announce it. Then what happened? We will be bankrupt because nobody will buy our charger anymore. So do you think this is a good design? So what can you do? Anybody has any suggestion?
We change the transformer specification.
Change what?
Transformer specification. As small as possible.
I couldn't understand. Change what?
The transformer, small.
Oh, small transformer. Okay. So the problem is you have 110 volt. 110 volt is huge voltage. So if you reduce the coil, two coil, then what happens? You can see 110 volt divided by J omega L. So if you only have 2 turns, then what is your current? 20 ampere. So can you use small transformer to put 110 volt in it? Can you do this? No. Then what can you do? So you cannot reduce the transformer. Why people use huge transformer? Because you need 200 turns. So you have to make 200 turns become huge. So you have no chance The reason is you have 110 volt input. Okay, so what can you do? So T-Ponium, what can you do? You design this circuit, but it is too huge. So what can you do? Do you have any idea? No. Then you don't need to come to our company tomorrow. Okay, you are engineer, you are master student, you know everything about electrical engineering. So you have to propose some ideas, right? So what can you do? So if you put a transformer here, what is the problem? The problem is you only can have 1 ampere or 2 ampere. Then you have to have huge inductance. If you have to get huge inductance, then the turn should be 200 turns. Then your transformer will become very huge, right? So how can you solve this problem? You have to go back to the fundamental idea. If you have a transformer, what is your voltage? Your voltage is 4.44 FN5, right? 4.44 FN5. What is phi? This is flux. What is fan ratio? What is F frequency? Right? But you have 110 volt here. So which means the frequency is only 60 hertz. And the flux is fixed, then the turn is 200 turns. If you have 200 turns, it is huge. There is no way to solve this problem. So what can you do? Can you increase your flux level? And you use, we call it is coal or steel. The flux level is fixed, right? You cannot change it. So flux level is fixed. Can you change 4.44? You cannot change 4.44. Can you change turn ratio? You cannot, because you need to endure 110 volt. So what is the other way to reduce your coil? So you have to increase your frequency. If we can change the frequency, not 60 hertz, we change to 1 kilohertz. Then what happens? Then we can reduce to 60 times. Then original is 200 turns. But if I can change to 1 kilohertz frequency, then how many turns do I need? I only need maybe 120, 12 turns, right? Then I can be very small. So what is the method to reduce the inductor? Increase what? Frequency. So if you go to airport to take an airplane, what is the frequency in airplane? 400 hertz, not 60 hertz, 400 hertz. Then which means everything in airplane can be reduced to 6%. If you need a coil or inductor or transformer, it's only 6% of the ground transformer, right? So they use this way to reduce transformer and the inductor. So what can you do? You have to give a high frequency. Then you go to Taiwan company you cannot give me 60 hertz. You have to give me 1 kilohertz power. Do you think that they will give you 1 kilohertz? They say no way. Everything is 60 hertz. Everybody accept 60 hertz. Then you say why? Traditional, right? Your generator is 60 hertz. Your transformer is 60 hertz. How can I change to 1 kilohertz? It is impossible, right? Impossible. Then this is your job because you are power electronics engineer, right? You have to solve the problem. And somebody go back to sleep and they try to solve this problem. So what is their answer? They say, we cannot change input frequency, and maybe we can do something. What can we do? We have 110 volt. We have 60 hertz, but we can use rectifier. We have rectifier. So this is input. We have rectifier. Then we have capacitor. Then we change to 150 volt, right? DC. And then what can we do? We can design H-bridge. So we can design H-bridge. Then we can design transformer here. So by using H-bridge, can we change the frequency? Yes or no? H-bridge can change DC to AC, right? So do we need a 60 hertz or we can increase the switching frequency? We can increase to any frequency, right? Because power electronics. So you can change to 1 kilohertz here. Then the transformer is 1 kilohertz. Then it becomes what? Smaller. And then, what can you do? You change here, so this is 150 volt. And then you have voltage, something like this, 150 volt minus 150 volt. Then you change, maybe change to, this is 10 to 1. So in this case, this becomes 50 volt. 50 volt. But the switching frequency is 1 kilohertz, right? And then what can you do? I can design rectifier. Then I can design capacitor. Then I can get the average voltage. So what is the average voltage? This is 50 volt. I can control the duty, right? So maybe my duty cycle is 40%. So it is 60 volt. So people think the better way is we have to change AC because the AC is 60 hertz. We cannot use transformer in this way. We have to convert AC to DC. Then we use transformer in this way. But this AC is obtained by power electronics. So we can change to 1 kilohertz AC. Then the transformer becomes very small. So we can change to 50 kilohertz to 100 kilohertz or 1 kilohertz. Then the transformer becomes very small and we can use rectifier, then LC. Then how about your size? Original, the upper one is this size. But because you can reduce transformer, so transformer become very small. Original is this. Then how about diode? Diode is very small. How about a device? Device is very small. So your charger can be put into your cell phone. Then you only bring your cell phone. So you don't need to bring two things because you could forget. Then it is more convenient. So do you think that the idea is good? Yes. So if you are an engineer, you have to think about philosophy, not only modification. So what can you do? I change the AC into here. But you say it is not a good idea. You have AC. Why don't you use original AC? Because original AC only 60 Hertz. I cannot use it. So what do? I change from AC to DC. No, AC to DC, and then what? DC to AC, then what? AC to DC. So do you think this is a good idea? If you want to go to Japan, then you go to bank. I change my Taiwan dollar into US dollar, and then I change US dollar to European dollar, and then I change European dollar to Japanese dollar. Do you like to do this? No, because efficiency is not good, right? So now what did you do? You change AC to DC. Then you change DC to AC. Then you change AC to DC. Right? So the idea is the same. You change NT dollars to American dollars, and then you change American dollars to European dollars, and then you change European dollars to Japanese dollars. Then you can ask, why don't we just change it from DC to DC? Because if you change from DC to DC, you cannot use transformer. So this is the reason. So you say it is quite complicated, but complicated get better. So finally, you can design a small circuit. So it is not easy to think about this method because originally you think it is too complicated, but finally it becomes better. So now people use this way, and we can design very small charger and high performance. The reason is we use high frequency. Then if we use high frequency, the transformer becomes small and smaller. So this is the reason. So we call this is switch mode power supply. So this is transformer. So transformer create voltage. The voltage is 4.44 Fn multiplied by flux. Flux is B minus AC volume, B minus area. So we can get this equation. So if we can increase frequency, what does this mean? The size becomes smaller, right? But we use the same flux density. So if I increase the frequency into 1 kHz, then I can reduce to 60%. If I increase to 10 kHz, then maybe I only use 2 turns. Then it becomes very small. So from this equation, you can understand the principle. If you increase the frequency, then you can increase your size because the flux density almost the same. So this is the fundamental idea people use, and then they design the isolated converter. So what is isolated converter? We need transformer. So you can see this is DC, and we use H-bridge to convert into AC, right? And then we use convention to reduce the AC, and we use diode to do rectify, and then filter, and then load. So what is this converter? We call it is full bridge converter, or H-bridge. This is 1, 2, 1, 2. So what is this H? So we call it is H-bridge or full bridge. And we call it is isolated DC-DC converter. This is isolated this is DC to DC. So how much capability, how many kilowatt can you design this one? Maybe maximum is 3 kilowatt, 3 kilowatt. So if you want to design the electrical vehicle charger, what can you do? And it could be 30 kilowatt, much larger, right? Then you have to find your topology. So if you use this topology, maybe only 3 kilowatt. So if you can use to motorcycle charger, no problem. But electrical charger could be a problem. So the idea is quite simple. We use H-bridge, we use transformer, we use rectifier, we use filter, then we can obtain the DC-DC converter with isolation. So what is the advantage of isolation? Safety, right? Because here, maybe quite high voltage, 600 volt. Here, we only have 20 to 30 volt. So safety is one issue. How about another issue? If you do not use this transformer, here, input is 600 volt, and your output is 5 volt. Then what is your duty cycle? So you have, if you do not have transformer, then you have this voltage, 600 volt. And then after rectify, what can you get? Then you can get this voltage, this 600 volt. But what do you need? 5 volt. So what is your duty? You can calculate the duty. So 0.866%. So here, if this is 1 millisecond, then what is this? Only occupy less than 1%. Is it easy to design? Duty 1%. Then if you create 1.5%, it is too large. If you create 0.5, it is too small. Can you create 0.99%? Not easy. So you find that it is very hard to design because you have turn-on delay, you have turn-off delay. In this case, only have maybe 1 microsecond. But after 1 microsecond, it could be like this. Turn on have delay, turn off have delay, right? But you only have small time interval. So you cannot design it because the duty cycle is too small, right? So what is the advantage? Then I can choose the turn ratio. If I can choose the turn ratio for the second side, maybe I can change to 6 volt. Then 6 volt to 5 volt, the duty cycle is 0.8. It is easy to design, right? So what is the advantage? If we have transformer, then transformer can create another turn ratio, voltage ratio. Then for the output, the duty cycle can be near 1 or near 0.5. Then it is easy to design. So this is the full bridge converter. And you propose this idea to your boss. Say, now I need a charger. So I want to design this charger. Then your boss say, how much device do you need? You say, I need 1, 2, 3, 4 IGBT. I need 1 transformer. I need 1, 2, 3, 4 diode. I need 1 inductor, 1 capacitor. Then what is the total price? You say the total price is this money, 5,000 for charger. Then your boss say, it is impossible. Do you like to buy a cell phone, 30,000, and then buy a charger, 5,000? No. And your boss say it is impossible. What I can do is 300. So can you design this circuit in $300? Impossible, right? You need 1, 2, 3, 4 device. You need a transformer here, high frequency transformer, and then you need 4 diode. You need inductor here. You need capacitor here. If you buy all device, it is at least $2,000. But you have to sell $300. Then you will be what? Bankrupt. And your boss say, this is your problem, not my problem. You have to propose your idea tomorrow. Otherwise, you don't need to come to my company, right? You are expert, right? So what can you do? So you need a charger, cell phone charger. But if you use this one, too expensive. So what can you do? Anybody has any idea? The performance is good, but it is too expensive, right? So what can you do? You have to reduce device. So can I remove this device? Can I remove this 4 diode? No way. So you have to think, what can you do? So we will have 10 minutes break, and you will think about this issue. Otherwise, tomorrow you won't go to company, right? You go there to eat by yourself. Okay. So we will continue after 10 minutes. So anybody need any